Hi there, folks. This is the practice chapter B, 10B test, and as always, I am the amazing Mr. Jansen. So away we go. If we take a look at this first one, this is an exponential growth type problem. And remember, we had two formulas for exponential growth. There was the y equals a times 1 plus r raised to the t, and that's the one that's asking us to use here. And this is no different from our other formula, and we'll talk about that in a second. But for this one, we've got an initial population of 2,200. Remember, that's our A value is the initial population. So y equals the 2,200 times 1 plus r. R is the rate. Okay, that's the 8%. And remember, anytime we have a rate, we want to express it as a decimal. So that's a 0.08. And then t is the time. And in this case, it's time in years, so that's the 5. And I'm just going to plug this in. And the first step to plugging this in brings us to our other form of this equation, which is the 1.08 in here, which is of the form, if we want to think about this, if we remember this one instead, this is going to be our y equals a times b to the x. Okay, and in this case, the other formula kind of gives you that b value by doing the 1 plus r, but the b value is the 1.08. But regardless, we're just going to plug this into our calculator and make sure you use order of operations here. You want to raise that 1.08 to the 5th power first and then multiply it by the 2,200. And it looks like the population is approximately 3,233, where we're going to round that up to the nearest person. Okay? For number 2, it's telling us that Bob earns $7.25 an hour for washing cars. And we want to write a function rule that describes this, describes the amount he's earning m in terms of the number of hours. So instead of having an x and a y, I'm going to have an m and an h. So m is going to be like my y, h is going to be like my x value. So if I think of this in terms of a linear equation, when he works 0 hours, he makes $0. So that's like our y-intercept. So the amount of money he makes is just $7.25 times the number of hours he's going to work. Okay, so this would be in a linear equation that represents that. However, if we're talking about a function, if we want this in function notation, we would write it as m of h. Okay, the function m in terms of the variable h equals 7.25 times h. So it's really the same thing, except we express y as a function of h. Okay, so either one of those answers really expresses this correctly. For this one, it says to match the property to each step. And so the first one, right here, in order to get this first step, I'm multiplying the 2 times the x and the 2 times the -5, and that's my distributive property, which is letter E. The next thing I do is I add 10 to each side, and when I add the same thing to each side of an equation, that's my addition property of equality. And then the last step, I divide each side by the 2. And when we're dividing each side by something, we could call that the division property of equality, but technically it's also the multiplication property of equality also. Some books don't even recognize division property of equality, but either one of those would be an acceptable answer. Okay, dividing by 2 is the same as multiplying by 1/2. All right. In terms of this last one, on this page, it says, what's the difference between associative and the commutative property? Remember, associative property we use when there's like 3 things or more typically, and we're going to change the order in which we do things using parentheses. For example, something like 4 plus 3 plus 5. If I have parentheses around the 4 and the 3, I would add those together first and then add the 5 together. But that's the same thing as if I were to add the 5 and the 3 together first. Okay, and notice I haven't changed the order in which it's written. I've changed the order in which I add these together by using those parentheses. That's the associative property. Okay, the commutative property is when I actually change the order in which this is written. So 4 plus 3, I would say, is the same thing as 3 plus 4. Okay, so I'm changing the order by physically moving the values. All right. And each of those is also works with multiplication. You could have done an example using multiplication as well. Number 5, it says you have $30 to spend on apples and oranges. The cost of the apples is $2. Each orange is $3, and we want to write a linear inequality that represents the situation. And it kind of specifies how it wants us to approach this. it tells us to use x for the number of apples. So when we think about the apples, if there's X number of apples and they cost $2 a piece, the price of the apples is 2 times X. It's $2 for each apple that I buy. Then it also tells me to use Y for the number of oranges. So if Y is the number of oranges, it's $3 for each orange. So it's 3 times Y to give me the total cost of the oranges. And then of course I'm going to add these together. And when I add these together, my total cost has to be less than or equal to the $30. All right, I can't exceed that amount. I have $30, which means I can spend that or less. So my inequality is 2x plus 3y is less than or equal to 30. And that's it. It just asks us to write an inequality. Number 6, it says to write the equation line that's parallel to y equals the negative 2/3 x plus 5 and passes through this point that's given. Remember, the two things that I need to write the equation line are the slope and the y-intercept. So for this one, the slope parallel lines, when I talk about parallel lines have the same slope. So this has a slope of negative 2/3. So our slope is going to be a negative 2/3 as well. If it was perpendicular, we do it opposite reciprocal, but this one's parallel, they're the same. Then I use a fresh y equals mx plus b. And I'm going to plug in what I know. I know that the slope is a negative 2/3. B is the thing that I'm looking for. I need to solve for B. I want to find B, so I need an x and a y value, and that's why they give me this ordered pair. The ordered pair is an x and a y value. So I plug the negative 6 in for x, I plug the 5 in for y, and now I just have to solve this for B. Over here, the negative 2/3 times the negative 6 is going to give me a positive 4. And now I just have to subtract the 4 from each side, and I find out that B equals 1. So my B value is 1, which means my equation is y equals a negative 2/3 x plus 1. And that's it. In the next one, it says the volume of the box is given by this trinomial. And we want to know what the possible dimensions of the box are. Remember, volume of a box is length times width times height. So I need 3 values here. Okay, so when I factor this, I need to be broken down into 3 things being multiplied. So I'm going to factor this thing. If I look, all of these have an x in common, so I'm going to factor the x out, which leaves me with an x squared plus 4x minus 21. And now the trinomial that's left inside here, I'm going to build a bridge. That gives me a negative 21. 2 numbers that multiply to negative 21 but add to a 4 are a positive 7 and a negative 3. And this one I can use my shortcut on because there's a 1 in front of this x squared, which means my 2 factors here are going to be an x plus 7 and an x minus 3. And then this x that I factored out initially just tags along for right. So now I have 3 things being multiplied. So these are my possible dimensions. It's the x plus 7, and the x minus 3. The 3 factors are my possible dimensions for the box. In number 8, it asks us if these could be the measures of a right triangle. Remember, all right triangles adhere to the Pythagorean theorem, the a squared plus b squared equals c squared. So if it's a right triangle, this is true. And if this is true, it's a right triangle. So I'm going to plug these values in. I just do 11 squared plus 12 squared equals 18 squared. So the 11 squared is going to give me a 121. The 12 squared is going to give me a 144. And then the 18 squared is going to give me a 324. So now I just see if this holds true. I'm going to do the 121 plus the 144, which gives me a 265. And 265 does not equal the 324. So since this is not true, it means that these could not possibly be the dimensions of a right triangle. Okay? So the answer here is no. In number 9, it asks me to solve the compound inequality. And really, if I were to ignore part of this, if I were to scribble this out, for this inequality, I would add 2 to each side. But if I were to scribble out the other end, for this inequality, I'll also add 2 to each side. So I'm just going to do all 3 pieces at once. Here to solve for x, I would add 2 to each side, but I'm going to do it to this side and this side as well. So I'm going to do it to all 3 parts. So that's going to give me a negative 3 is less than a 3x, less than or equal to a 12. And now, once again, to get x by itself, I have to divide by 3, but I'm going to do it to all 3 of these pieces. So here that gives me a negative 1, less than x, less than or equal to a 4. And then I just want to graph this real quickly to make sure that there's overlap. With an and inequality like this, we need to have overlap for it to be true. So I've got an open dot here, a closed dot here. I want to be bigger than this value, but smaller than this value, and so they're going to overlap in between. So now I know that this is a valid solution. Okay? Number 10, we want to match the function with the transformation of the function y equals the square root of x. Remember, adding or subtracting does different things to this function. Adding or subtracting inside the radical moves it left and right. Adding or subtracting on the outside moves it up or down. Okay, so right here I'm subtracting 3 inside the radical. Inside the radical moves left and right. And whenever we're inside, it always does the opposite of what we might think. Minus 3 makes me think it would move left, but it always does the opposite. So this one's going to move to the right. So this is going to shift to the right 3 units, which is letter C. For the next one, I'm adding it on the outside. And when we do things on the outside, it does exactly what we think it's going to do. Okay, so adding on the add or subtracting on the outside moves up or down. Since we're adding, it's going to move it up that many. So that's letter A. It shifts up 3 units. Here, I'm adding on the inside. Again, it does the opposite of what you might think. So that's going to go to the left 3 units. And now this one, I'm subtracting on the outside. It's going to move down 3 units. And then the last one, when I multiply it by 2, it's just going to double all of the y values. It's going to multiply all of them by 2, which is letter E. Okay, and those are some of my transformations. For these next couple, we just want to solve each, and we got to check our solutions. And it's always important to check your solution to make sure we don't have any extraneous solutions. So for this one, we have to isolate the radical. So I'm going to subtract the 4 from each side. I have to get the radical by itself. That's going to give me a 5 equals the square root of x. And now to undo the square root, I have to square each side of the equation. So I raise each side to the second power. Here I get a 25. Over here, the root and the exponent cancel each other out. So I'm just left with the radicand, just left with the x. So I find out that x equals 25. And the last thing I do is plug this back in. And when I plug this one back in, it does work. So that is a valid solution. So x equals 25. For the next one, again, we got to get the radical by itself. Right now, there's a negative 3 that's kind of in the way. So to undo multiplying by a negative 3, I have to divide by a negative 3. So that's going to give me a positive 3 equals the square root of r. Now the radical is by itself, so now I'm going to raise each side to the second power. Here I get a 9. Here, once again, the square root and the square cancel each other out. I'm just left with the radicand, which is r. And now, of course, I want to plug that back in. And when I plug the 9 back in, it does work. This is a valid solution. So r equals 9. All right. For this one, the radical this time is already by itself. The square root is all by itself on that side of the equation, so I can go right to undoing the square root by squaring each side. So I'm going to raise each side to the second power. That gives me a 25 equals 3h minus 10. Again, the root and the exponent cancel each other out. Now I'm going to solve what's left. I'm going to add the 10 to each side. So that gives me a 35 equals 3h. And then, of course, I divide each side by the 3. And I'm just going to leave this as an improper fraction. H equals 35 over 3. And once again, I want to plug that back in. That's an ugly looking 3. Let me try again. So I plug that back into the equation. And this one does work when I plug it back in. So again, I get a valid solution. So this is my answer.